Okay, everybody, welcome back. So this is going to be part 3, and this will likely be our final part for our eye dissection. So if you recall, part 1, we talked about majority of the external part of the eye. Part 2, we got into talking about maybe parts of the pupil, parts of the iris, parts of the ciliary body. We talked about the lens, vitreous humor. And so what we'll finish here is now we're going to look at the back side of the eye. So again, just for orientation here. Okay, let me turn this right side out. So here's anterior part of the eye. Okay. We opened it up, right? So here we're looking at back side of the eye, so posterior and anterior, okay? This is what we looked at last time, right? We kind of turned this inside out and looked at this region. So now we're gonna focus our attention back here at this posterior margin of the eye, okay? So a few things. We'll do a review of some of the layers, right? So this is our sclera, right? So if you recall, our thick outer fibrous tunic, okay? This is our sclera that I'm holding here with the probe. Remember, it's continuous with the cornea anteriorly. You have this dark region here. This is what's called the choroid, okay? The choroid right here. Now, this is a sheep eye, okay? This is not a human eye. So they have and other animals, other vertebrates, other mammals, have a structure that we as humans do not have called the tapetum lucidum. Okay, the tapetum lucidum, and that's this kind of blue-green structure that you see all in here, right? And it's essentially part of this this choroid layer here, right? So you can see it's kind of all one layer if we start to peel on it, okay? So what this is doing, if we peel part of the retina away, you can kind of see part of it over there as well, okay? You can see some of it. If I remove the retina, you can kind of see some of it under here over as well. So what this tapetum lucidum is doing is it is essentially allowing more light to be reflected back onto the retina, which allows for better vision in low light environments. Okay, so for better night vision, essentially. Okay, and so this is an anatomical feature that we as humans do not have, but animals such as cows and dogs and sheep and whatnot, they do have this tapetum lucidum. Okay, and then the inner layer here, and this is sometimes called the vascular tunic, the choroid. Okay, so sclera, fibrous tunic, choroid, vascular, this is the fibrous tunic, choroid is the vascular tunic, and then here we have finally our retina, right, which has kind of been torn on this side. You can kind of see part of it right here. If we kind of try to flatten it back out, you can kind of see how that was stretched out, right? But you can very easily take a finger, take the end of a probe, take the end of tweezers, end of scissors, and just move and tear the retina, right? So if you've ever heard of something called a detached retina, right? This is what happens. There's a portion of the retina that becomes detached from the underlying choroid, right? So you see how you can just peel that off very easily, right? I can just take this and just peel it off, right? That's what's happening in a detached retina, right? Now you can kind of see here, and in this image here, it looks like it's right here at the tip of my probe, where all this retina is kind of radiating to one single point. It looks like in this eye, it looks like it's coming right here at the tip of the probe, right? This is something called the optic disc, and we alluded to it in the first video, and we said the optic disc was essentially where the retina is leaving the eye, or you can think of it as where the optic nerve is entering the eye. And information is being carried back out through the optic nerve, right? So if we turn this over, right, here's our optic disc, right? We should be able to find the optic nerve somewhere near, right? And there it is, right? So there's our optic nerve, okay? There's our optic nerve. And if we imagine where this is, right? If we just rotate the eye till we look at the inside, there's the optic disc, right? Optic nerve on the outside of the eye, optic disc on the inside of the eye, right? So right here, right there. You can confirm this, and we're gonna destroy the retina here, okay? So what you can do is you can take the retina and you can peel it all, right? So we'll peel it kind of from all sides, and you'll notice that it stays attached, okay? It stays attached in one area. So notice, all this here, we can move all this, right? We can just peel it nicely, no big deal, all right? But you'll notice it stays attached in that one area, right? So if we continue peeling the retina, continue peeling it, right? All this, notice it's anchored there at the optic disc, right? We can't move it beyond that optic disc, right? Because that's where the retina is leaving, all right? So we can move this all around, and you'll notice it's pivoting all around that one point right back here at the tip of my probe, right? That's the optic disc, okay? That's the optic disc. So, and again, we can continue moving this, and you'll notice it just stays attached at that one point, all right? So again, all this yellow tissue, all this is retina. So, excuse me. So at this optic disc, right, we said this is where the retina, these ganglion cells that make up the innermost layer of the retina, this is where they're leaving. This is also called our blind spot, okay? The optic disc is our quote-unquote blind spot. And the reason for that is there are no photoreceptors present at the optic disc, right? So right here, there are no photoreceptors. So any light that is focused on the optic disc, we are not able to perceive, right? So this leaves us with a blind spot, okay? Now, in reality, right, whenever you look outside or you're looking at a page, you're looking at your cell phone or something or a book, you don't perceive any blind spots, right? And the reason for this is because you have two eyes, okay? You have binocular vision, you get this crossing over. And so what is a blind spot in one eye, the other eye makes up for it, okay? You can test this pretty easily. You can take a note card. On one side, you can draw an X. The other side, you can draw a circle. And you can look up how to do this online. But what you're doing is you're going to cover one eye. You're going to cover, say, the left eye, and you're going to look at the X on the left. And as you move the card towards your eye, you'll notice that at a certain point, the shape disappears. Okay, the shape disappears. And when it disappears, that is when the light is being directed on that particular eye's blind spot, right? And the reason you cover one eye is because if you had two eyes active at that point, you wouldn't perceive it as not being there, right? Because you have both eyes working. So by covering one eye up, you're relying solely on one eye. When the light from that note card strikes the optic disc of the uncovered eye, you no longer see the object, right? This is easier, it's easier done than described in this case. I probably didn't do a very good job describing it, but this is a good illustration of the blind spot, right? And so again, this is our optic nerve, our retina with the optic disc, okay? Now, there are other areas on the retina that we may not have been able to really see all that well before we kind of destroyed it. Region is called the macula, which is kind of a central region in the eye. The macula lutea, and then a part of that, there's something called the fovea, or the fovea centralis, which is an area of the eye that is highly concentrated, area of the retina that is highly concentrated with photoreceptors, specifically cones. And so the fovea centralis is sometimes referred to as our area of best vision, right, of our central vision, our highest acuity vision, right? And so when light is focused there, we're able to perceive it very sharply and very acutely, okay? Okay, I think that's everything I wanted to discuss here with the eye. So please reach out if you have any questions. Again, go back and watch the previous parts if you haven't already done so. And don't hesitate to reach out if you have questions.